start at the beginning.
You know, numbers are just like you and I. They like to travel in pairs. And when you get a bunch of pairs together, well, you kind of have a little party.
Do you mind telling me what this is all about, mister?
Well, that's what a relation is. It's a group of pairs, or a set of ordered pairs. Here's some examples. This we'll call relation A. It's got the pairs 4, 6, and another pair 0, 7, 6, 2, and 2, 6. Now note that these are ordered pairs. So 6, 2 is different than 2, 6. Here's another way to write a relation. This is the relation B, which is the set of 3 ordered pairs. The pairs 1, 2, 3, 4, and 5, 6. Starting to look a little like points, aren't they? Here's another one. It is a relation, relation C, the set of 1, 4, 1, 3, 1, 2, and 1, 6. And yet another, relation D. Same idea, a set of ordered pairs. And don't forget what I told you.
Wait a minute.
Order counts. These two pairs are different. But we're going to get in the habit of listing X, then Y. It's kind of easy to do because they're in alphabetical order.
Now look at here.
The set of all the first numbers, or we'll call them the inputs, in a relation is called the domain. All these red numbers are the domains, if you would, of these various relations that I just showed you. Basically, it's all the X's if you have points. We also call it the independent variable. X is the independent variable because you get to pick it. Okay? You get to independently pick it. Now, that's the first numbers.
I know you are, but what am I?
Well, the second numbers, or the outputs of a function or relation, if you would, is called the range. All the second numbers. Yes, all the Y's. You're right. Now, with the first numbers, you get to pick them. They're independent.
Certainly.
But the second numbers depend on what the formula is of the relation. Okay, so that's going to be called the dependent variable. The Y's are the dependent variable. Their value depends on what the formula is to map from X to Y. But let's stick with, forget the formula for now, let's stick with naming the domain and range. In this relation, what is the domain? Well, it's the set of all the first numbers, of all the X's. The set 1, 2, 3, and 4. And the range is all the second numbers, 2, 4, 6, and 8. Very simple, isn't it? Well, let's make it a little bit more difficult. In this case, the domain is the set of all the first numbers. So it's the set 0, 1, 2, 3. Now the range is the set of all the second numbers, but we never list a number twice in a set. So the range is simply the set 5. Another way to say that is that it's all the possible second numbers.
Oh, right, guy.
Okay, only list each value once. Now let's create a graph of a relation by throwing some points on the graph. That, remember, a point is a pair. Each point has an X and a Y. Now, what's the domain and range of what we have pictured here? The domain is going to be all the X values. Well, we can look at this, and the X's moving from left to right are going to be, let's see.
Perhaps I could be of some assistance.
Okay, let's throw an axis in there. The X's are going to be -6, 0. Note I'm going from left to right, from smallest to largest. 2 and 7.
Cool.
Now that was the domain. The range is going to be all the possible y's. So we're not going to go from left to right. We're going to go from bottom to top. Let's get our little numbers on the axis there. And from bottom to top, the y's are going to be the set of 0. That's how high that is. What's the next one? 1. Now be careful. What's the next one moving up? 2. We're not moving from left to right, are we? And 5.
Correct, boy wonder.
And that is the domain and range of this picture.
Do that again.
Okay, let's do another. Throw a couple more points on there. Little trickier. The domain, remember, is all the possible x's. The set of all the possible x's. And in this picture we have
No problemo.
2, 4, moving from left to right, 6, and 8.
Yes.
Now that's the domain, the possible x's. The range, of course, is the possible y's. I should say the set of all the possible y's. It's going to be a little smaller here, isn't it? Because the possible y's are 5. What's else? 5.
I know that, dude.
We don't say it again, do we? 5
I know that, dude.
and 5.
Believe it or not.
So that's the range. You just list 5. Now some people like to say the domain is how wide a picture is and the range is how tall a picture is. I think we'll get an idea of that when we look at this. We really can't list all the points. Let's start
That's the fact, Jack.
by naming the domain, which is all the possible x's. We can't list them all, but we know they go between these two numbers. And we're not going to include where we've circled. I hope you get the idea. So it's somewhere all the points between 2 and 4, not including 2 and including 4. Remember, we're going from left to right. The notation we'll use here is going to have to name an infinite number of points, isn't it?
Excuse me?
So we'll have inequality notation. Now this is a little fancy. This is red.
Nerd alert.
All the x's, and that line is such that, all the x's such that x is, you'll read the x first now, x is greater than 2 and less than or equal to 4. Note that we're interested in all the possible x's, so we say the x first.
Now what am I going to do?
Now to do the possible y's, we're going from lowest to highest. And in this case, we're going from 0 to 6. We're not going to include 0, but we are going to include 6. So we're talking about, once again, an infinite number of points. So we'll have to use inequality notation once again.
Excuse me, Professor Brainiac.
This is what it'll be. It'll be all the y's. Notice the range is y's now this time. All the y's such that, remember that means such that, I'm going to read this with the y first. All the y's such that y is greater than 0 and less than or equal to 6. And that is the range. That's about the only way to do it. Okay, let's review inequality notation. When we have a solid circle, that means we include the endpoint. We're going to do that when we have a greater than or equal to and a less than or equal to. When we have an open circle,
You're absolutely correct.
that means we don't want to include the endpoint. So that would come up when we have a less than or a greater than, no or equal to if you would. Okay?
Alrighty then.
Let's try another. Now this green graph is going to have a domain defined by all the possible x's. Now once again, we're going to go from left to right. Our lowest x is 0.
To infinity and beyond.
Our highest x goes on forever. So what are we going to do here?
Welcome to Fantasy Island.
Well, we're going to have to use inequality notation again, and it's going to be such that x, the set of all x's such that x is greater than or equal to 0, and that sends it on into infinity. The y's are a little easier this time. The y is just 4. Now we could just list 4, but you might also see something fancy like this, which would be read the set of all y's such that y equals 4. Don't let that scare you.
As always, should you be caught or killed, the Secretary
Oh boy.
disavow any knowledge of your
Let's
actions.
try this one. Hopefully you can see once again that the domain measures kind of how wide something is, and the range measures how tall or short it is. The domain is all the possible x's. Now this thing goes to the left forever and to the right forever. How are we going to name all those points?
Pay attention, son. This is for your own good.
Notice the arrows say it goes on forever in that direction. Well, what you can say is the set of all real numbers, and we even have a symbol for that.
Well, ooh la dee da.
If you see this R, it means all real numbers. Okay? That's a possible domain. Now the y's are all the possible, or the range is all the possible y's. It doesn't, we go from lowest to highest, it doesn't go down all the way to hell, does it? It starts at 0,
To infinity and beyond.
and it goes up forever. So it goes from 0 to infinity. Well, how would we say that? We have to symbolize it with the arrows, but to say it in set notation as the range, we'll say all the y's such that y is greater than or equal to 0. And that would be the range.
Hasta la vista, baby.
Okay, go try doing that on your own. Do the homework.